In the last video, we talked about how to break up a program modularly, what ends up in the bin directory, the interface rational.h ends up in the include directory, and the source files include up in SRC. When we go to build a project in Eclipse, what happens is Eclipse looks for a file called Makefile, and that Makefile is actually run, and the Makefile determines what's going to happen in the build of this project. So let's take a little closer look at this Makefile. First thing we have up here are variables, and we can set these variables equal to what we want. So we have a variable called cc is equal to gcc. This is the compiler that's going to be used. cflags is equal to -g -wall. So this says we're going to compile with debug options, and -wall says enable all warnings, show all warnings. And then objects, these are going to be the two object modules that objects is going to equate to. And what happens is these variables actually get textually substituted into places down here as the Makefile executes. And you might ask yourself, why do we want to have these variables? Well, what's nice about this is if we want to use a different compiler, all we have to do is come up here and change GCC to, say, maybe CC. If we want to add more flags or delete flags, we can just change them in one place. If we add more object modules, we can just go ahead and add them on over here accordingly. So it really adds to the maintenance and the flexibility of your Makefile, makes it much easier to maintain. Then we come down to this .phony. And a Makefile, basically what's going to happen is either we're going to execute a command or we actually want to produce a file. This .phony all clean valgrind tarball, so all so this .phony right here is a target. These are dependencies over here, and in this case with the .phony, what we're saying is that each one of these targets are phony targets, meaning they're not going to produce a file like this one down here. You can see that this is not a phony target. We're actually going to create an executable called rational driver. And these targets, so again, this is the target, these are the dependencies, so we come down here and all is dependent on rational driver. Rational driver is the main driver that's produced, the executable that's going to be produced for the entire program that's going to run in this Makefile video project. So all depends on bin/rational driver, and now we come down here and bin/rational driver depends on the object module rational driver.o and the object module rational.o. Now what this says is, and how make works is, if this target rational driver is out of date with either rational driver.o or rational.o, then do this next line. Now this next line says $cc, so in essence this is GCC, and the flags -g -wall, and -o bin rational driver basically says what's going to happen is the objects rational driver.o and rational.o are going to be linked together and produce rational driver, which is actually what we're going to go ahead and execute. Now that's a mouthful and it's complicated. The other thing that's important here is that you'll notice if we click here and I space over 1, you'll notice that's not space. This is a tab. It's imperative that a single tab be placed in front of this command. Okay, otherwise, Make's going to have a problem. So once again, the target is dependent on these two dependencies right here. So the target rational.driver dependent on rational driver.o and rational.o. If these don't have the same timestamp, do this line, which again, link these two objects, so rational driver.o and rational.o, link these two objects into rational driver. Okay, similarly down here, bin /rational driver.o. So this rational driver.o is dependent on rational driver.c and rational.h. if the timestamp of rational driver.c or rational driver.h is not the same as rational driver.o, do the next line, which says gcc -g-wall, and in this case right here, this -c says we're not going to create an executable. You're going to instead take rational driver.c and create rational driver.o. Because all we want to do in this case is we don't want to try and produce an executable, we just want to produce the object module rational driver.o. Same thing down here. If this target is out of date with these dependencies, do this next line, which is compile rational.c into rational.o. And so the Makefile is in charge of all of this management and making sure that everything is up to date. Now, one of the cool things here is that if only a portion of your program changes, only the portion that changes needs to be recompiled. Meaning, if we change rational.c, then rational.c and rational.o will be out of sync. And so we'll execute this command, which will create rational.o, but nothing happens with rational driver.o because rational driver.o right here is not dependent on rational.c. Again, that's a mouthful. You really have to think about this. Where do all of these come from? Where does this Makefile come from? How does it happen? Again, go back and take a look at rational.c. Rational.c right here, if we go to the top, you see that rational.c includes rational.h. Okay, that's important. Rational.c includes rational.h. So if you go to the Makefile, rational.c, so rational.o clearly is dependent on rational.c and also dependent on rational.h. If we change rational.c or we change rational.h and it's out of time sync with rational.o, then do this command down here, which says, again, recompile rational.c into rational.o. And then again, if rational.o changes, well, what happens? Well, you can see that the rational driver then is going to be out of sync with rational driver.o or rational.o. And again, if we just change rational.o and this is out of sync with this, execute this command, which then says link these two object modules together to produce the final executable right here, rational driver. Wow. So that's tough. That's tough stuff. You're going to have to take a look at this. You're going to have to play with this. Again, in the previous video, I put out a copy of this sample code, and you can see how it works. So I want to show you a couple of other things that are pretty cool. So from the command line, I'm going to open up a command line, and I'm going to clear the screen, and you can see that we're in the Makefile video. So let's take a look at what's in this. You can see bin, include, Makefile, and source. So we know what's in bin, we know what's in include, and we know what's in source. So right now, first thing, if we say, so let's take a look at this clean right now. Clean has no dependencies. And clean, if we say make clean, clean will always run, and what's going to happen is we're going to remove rational driver and any object modules that exist in the bin directory. Okay, so let's take a look at bin, take a look at what's in bin. Okay, so we see that those three files exist there. Let's go back up. Let's do make clean. And you can see that the command was run, remove the rational driver, remove bin rational driver.o and rational.o. And now let's go back into, again, there's easier ways to do this, but I'm just, if you're here, chances are you're kind of just beginning this stuff. So we'll change into bin again, do an ls, and look at that. All of the files are gone. So if we come back up here, now what we can do is we can do a make. So make actually is a command that looks for a file called Makefile, and it's going to go through and execute what's in the Makefile. So if we say make all, it's going to start up here. All is dependent on rational driver. Well, rational driver doesn't exist. Rational driver is depending on the two object modules. They don't exist. So each one of these commands make's going to go through, check all the timestamps, whether the files exist, do its thing. So once we do a make all, then you can see that this execution happened. So the first thing was rational driver was compiled into rational driver.o, rational.c was compiled into rational.o, and then the two object modules were linked together into an executable rational driver, and that exists in bin. So that if we type bin and rational driver, we go ahead and execute that, our program executes. Pretty cool. So another thing we can do here, just let me show you a couple of other things. If we change the timestamp using touch, so we can say touch include and rational.h. That changes the timestamp. As soon as we change that timestamp, then if we type make, the bottom line is we come up here, rational driver is dependent on rational driver.o and rational.o. Well, those timestamps are okay, but rational driver.o is now out of sync with rational.h. Same thing down here. And then once these are recompiled, then this is going to have to happen. Make takes care of all of that. So if we do a make, you'll notice that again, the same things happen. Now, one last thing, if we say touch src, so in the source directory, if we change, so again, touch just changes the timestamp. If we say touch src and we do say rational.c, so the thing we're changing is rational.c, and then right now if we do make, nothing should happen with rational driver.c. What should happen is rational.c, we come up here and rational.o will be out of sync with rational.c, so this will happen, and then this rational driver will be out of touch with rational.o, and then this actually should happen. So let's take a look at what happens. There you go. Just those two lines are executed, and wow, that's a lot. I'm going to stop. You need to go back and review this. There's some other cool things here. At Pacific, we use valgrind to check for memory leaks and memory that's accessed inappropriately, and then we've got some other things that show us how to tar up these files and send them elsewhere. And I'll take a look at this in some subsequent videos.